Okay, so now this time we have a third order homogeneous equation. And the method of solving these is very similar. You have, mm, you still write the auxiliary equation and try to find the roots of the auxiliary equation. So the auxiliary equation here will be r cube. So r cube minus 3r squared minus r plus 3 is equal to 0. And try to find the roots of this equation. And the roots of this one can be found by factoring by grouping. So from the first two terms, you can factor out an r squared. R squared factors out from the first two, and you are left with r minus 3. And from the second two, you can factor a negative 1. And you get r minus 3. Equal to 0. And then this is r squared minus 1 and r minus 3. And when r squared is equal to 1, we get r equals plus minus 1. And from here, we get r equals 3. So we get three solutions. R is equal to 1, negative 1, and 3. And if the three solutions are distinct, we will just do this case where in a cubic equation where the three solutions are distinct. So then it has a very similar form to the two distinct roots. Let's go back to that. So we know that for two distinct roots, the solution is like this. Once again, this is a general solution because we do have conditions, a general solution. And then you add a third one, plus C3 e to the R3t. Okay, so this one is below. Okay, and then we substitute the three roots. So e to the t, e to the negative t, and e to the 3t. Okay, and now the initial conditions involve the first derivative and the second derivative as well. So we will need to find the derivatives, two derivatives. So this is y of t. And you get y prime t. Y prime t. Okay, so when you take the derivative of this, let me just copy this. Derivative of C1 ET is just C1 ET. For C2 e to the negative t, you will pick up a minus sign by the chain rule, and here you will pick up a 3. Okay, and then when you do the second derivative, y double prime t, you get, okay, let's copy. So, yeah, you just copy this one, take the derivative of this. So C1 ET is just C1 ET. And for the second time, you'll pick up another negative that will make it a plus, and then you will pick up another 3 for the third term, and that will make it a 9. All right, so now y of 0 is 6. So we do this. Get y of 0. And when you put t equal to 0, this goes away. E to the 0 is 1. This also goes away. This also goes away, and that's equal to 6. So let's call it equation 1. And then y prime 0 is 12. So y prime 0 this will go, this will go, and this will go too. And that's equal to 12. And then y double prime 0 is 30. Okay, now this is a system of 3 equations and 3 unknowns. Normally you have to do a lot of work, but here it's comparatively easy because you can like add 1 and 2, and C2 will be eliminated, and then you can add 2 and 3 and C2 will be eliminated. So we can write adding 1 and 2. So we will get 2C1 2C1, right? C1 plus C1 is 2C1, and C2 minus C2 cancels away, and C3 plus 3C3 is 4C3. Or C3, and then equals to, and 6 plus 12 is 18. Okay, let's call this 4. And then when you add 2 and 3, again, C2 will be eliminated. So adding 2 and 3. So we'll again get 2C1. So let's go. So C1 plus C1 is 2C1, minus C2 plus C2 goes away, and 3C3 plus 9C3 is 12C3. And 12 plus 30 is 42. Let's call this 5. Now, if you subtract 4 and 5, so subtract 4 from 5 or 5 from 4, uh, you will eliminate the C1 and you will get C3. So subtracting no. Okay, subtracting 4 from 5. So you see, you'll have, so 2C1 minus 2C1 will just go away. And then you have 12C3 minus 4C3 will be 8C3. So have 8C3. And then 42 minus 18 is 30. And then when you divide by 8, you get C3 is equal to, okay, 30 divided by 8 is 3.75. 3.75. Okay, and then you can substitute C3 in any of them. So let's say substitute in this one. 3.75. Okay, so 4 times 3.75 is 15. 18 minus 15 is 3. And 3 divided by 2 is 1.5. So C1 will be 1.5. And then when you substitute C1 and C2 in this first one, C1 is 1.5. C2 is to be calculated. C3 is 3.75. Okay, so C2 will come out to be, so these two add up to 5.25. So C2 would be 0.75. So now we have all the three constants. So we go back to our general solution. So and substitute the constants. So C1, so 0.75. So C1 is 1.5. C2 is 0.75. C3 is 3.75. Okay, 1.5 ET plus 0.75 E negative T. E power negative T plus 3.75 E power 3T. Okay, so let's see if we made an error. minus 3y prime minus y prime plus 3y. So let's see. Minus 3y prime minus 5. Okay, so r square r minus 3, right? Minus 1 r minus 3, right? R minus 3 r square minus 1, right? Right. C1 e to the t, C2 e to the negative t, right? Everything right until now. Derivative is fine. Second derivative is fine as well. Okay, C1 plus C2 plus C3 equal to 6. C1 minus C2 plus 3C3 is 12, right? Plus C2 plus 9 is right. This is fine as well. So, oh, I don't know. For some reason, I said 42 minus 18 is 30. 42 minus 18 is 24. So C3 is 3 actually, not 3.75. And 2C1 plus 4 times 3. 4 times 3 is 12. 18 minus 12 is 6. And 6 divided by 2 is 3. So C1 is also 3. And then that would mean C2 will be 0. Because this is 3. And this is 3. So C2 will be 0. Means this term will not be there. Let's double check. The 0 makes me kind of suspicious. So C1 and C2 equal to 3. C1 and C3 equal to 3. So 3 times 2 is 6. 4 times 3 is 18. 3 times 2 is 6. 12 times, yeah, it looks right. So it means C2 is 0. So this second term will disappear. And you will just have 3et plus 3e3t. 3et plus 3e3t. Okay. That ends the section.